back to Tools and Track. What are we doing in this episode?
Don't know, I just got here.
Yeah, we're very fragmented at the moment. I've got about 300 things going on at once. We've got steel arriving very soon for us to start making floors up with. We've got hubs in various states of disarray. And as you probably gathered from the previous episode, I'm halfway through arms and I'm not getting any further forward. So in this episode of Tools and Track, we finished something. The question is what?
Tommy, what are you doing?
I'm earning my Blue Peter badge, clearly. We're doing a lot of cardboard design, which is a term that I am sick to the back teeth of hearing.
Thank you, Bomb.
Right, we get it, cardboard design, really clever because it's like CAD. So yeah, what we're doing here is templating out all the steel. I'm about to place an order for a lot of aluminium. I'd like to see how much of it I can get on one sheet. So we're putting a bit of forward planning into something for a change. And I'm going to see, once these are all cut out, what my major sections are going to sit like on a 1.25 by 2.5 sheet. I've done a start on this and the big man once again has kindly agreed to come down and give us a hand. So, do you want to play with cardboards?
Cardboard dated design. Can we get the funk out? So, the transmission tunnel?
Yes.
All four sides of it?
Well, no, not specifically all four sides, but a good chunk of it. The bottom of the transmission tunnel is going to be open to atmosphere because once this car actually goes on the road, we still have to be able to do maintenance on it. So I need to be able to get the prop out. That has to go in and out from the car from underneath. So we're going to do the 2 floor pans there, and then there's going to be a spot in the middle. However, the rest of it will need a good chunk of steel. I brought this cardboard out because
It's got staples on it
Ah,
that have injuries.
you can take it out, it's fine. We are going to have to completely encapsulate where the passenger goes, and the driver for that matter. So all of this section here and all of that up there will need to be covered in aluminium. Yes. Now what we have established so far is this section here we've sheeted, but this section and this section I quite like, if at all possible, to get on one sheet.
What we're going to do is we're going to have a single sheet cut into here, which I get sealed onto this one.
Yeah.
Runs along here, all of this is fine until we hit here,
Yep.
and then it needs to
And then along the bottom, it'll need to kink around that, and then it'll need to continue up here, kink around that, go up there, kink around that,
and think around that.
yeah, and back down.
With my limited understanding of how sheet metal works, that sounds like it's not going to happen.
It will.
I admire your confidence. I don't suppose you've got any longer cardboard.
That's a floor plan. Please don't ruin that one.
I was thinking this looks really suitably close to the right side.
It will be, being the floor plan.
Aye.
So, one thing we're definitely going to look at this week is finishing these rear arms. Now in last week's episode, we actually didn't really get very far, mainly because I didn't have the correct parts, but this time I do. So, we've got our bracket made, which looks a bit like this. Now we need to do the rest to get it onto the car. And to start all of that, we need to make a jig. Our diagram, specifically here, calls for a wishbone, looks a bit like this. Now, we are going to ignore all of this part here because it's getting built separately. All we're going to weld in our jig is the boss here, the two arms, and the two bush supports. So the sizes that I need to make a jig for is basically all of the outside of this. And that is 168.85 millimeters out the way from the body and 185 millimeters wide total length bush to bush. So that's what we're going to make.
So I've finished my masterpiece, frankly. Which we'll call this
If it finished, then I'd hate to see it started.
We'll call this the Hodor Lisa.
Okay.
How you're going to get a panel in here, I mean, it's just not going to happen, let's be honest.
You think so?
Which is really convenient because I accidentally cut the cardboard when I was cutting this hole here, too long all the way across.
Right, prove a point.
Ah, f*** off, just f*** off.
Sorry. Yes, this jig is simplicity in its finest form. It is just inch by inch angle iron, which I've set out those measurements to and welded perfectly square. That will give us fixed outer references that I can clamp all the individual components to and make sure that they don't move. But I hear you ask, what about the clamped component that needs to go in the middle, the camber adjuster? Well, we've welded on a pair of tabs exactly in the middle, which will locate that so it doesn't bugger off. Now, I know what you're thinking. This seems like a tremendously simple, and if truth be told, probably too basic a jig for it to work. Well, it's not. Think about it. All it needs to do is locate that for welding. Therefore, it's going to work. Why go to town making fantastically oversized jigs if all you're making is two arms out of it? As long as this guy works, I'm happy. And if it does work, I'll take you through the process of how I made it on the lower arms. But that's another episode. Okay, so that's the rear arms done, jig work sorted. All that remains now is to put our U-clamp on with a bit of threaded bar and we're finished. However, it's not quite that simple because whilst I have managed to secure the correct 18mm threaded bar, attaching it onto the U-clamp is going to be tricky. As you'll know, getting a weld on and making sure it's strong as possible is bad enough on the frame when we're thinking about triangulation. Putting just a simple bar onto a U-clamp without any form of actual reinforcement is probably going to give us some problems with strength. So what we're going to do is we're going to drill not an 18mm hole but something close to that through the absolute centre of our U-clamp. Then we're going to grind down a bit of thread off of the bar and make that so it's an interference fit through. Once we've done that, we're going to weld a slug weld around the outer face of that, making sure that it's basically a bolt that's been welded in. Following that, I'm also going to weld up the other side as well. The reason being, more weld the better. But I also need to make sure that when we're doing this weld, I don't bugger up the threads because I do not have a fine thread M18 tap kicking about. So let's not weld it to a point where I can't actually get the adjuster back on and off of it. So I'll need to be a bit creative with that. However, think about an idea. so bodge ahoy. It's often prudent when you're balls deep in a project like this to take a break from time to time, and this is one of those times where I start another fantastic distraction. You've probably been wondering why we've been fanning around with cardboard and making such a big deal of it up until this point. Well, let's go on a little road trip and see an old friend to explain that. So we're at StrongBroo headquarters here with the mighty Neil. Once again, you will see him in other episodes here if you want to get a catch up, and we're discussing aluminium.
Yes, much of it.
So we're going to skin, as we've discussed, the bottom of the car, and there are two different samples here. Now we've done the first scuttle in something very similar to this.
This is actually the old floor off my Formula Ford. This is the normal grade of aluminium, which is 1050, which is the regular stuff you get out of the metal suppliers. And if you'll allow me to demonstrate without banging anything, it's pretty wibbly wobbly. This is what's known as T6 aerospace aluminium. So this is exactly the same weight as this. Sounds different. No wibble wobble.
Brilliant.
In fact, I'll just give you the tap test on this one.
Does this just rivet on in the simple fashion we'd normally use?
Well, this has got. I went for all countersunk rivets. I very much recommend using the bits that have the hole and countersink in one.
Okay.
It will be stuck on with this, colloquially known as helicopter glue. Strictly known as 9323, 3M 9323, but it's colloquially known as helicopter glue. It is insanely strong.
Right.
You can stick a couple of bits of 3mm steel together with it along the bottom edge, put the hydraulic ram between them, and the steel will break before the glue breaks.
Okay, well that's promising.
So the thinking is that by going for the more rigid metal on the floor, that you're actually adding significant structural rigidity to the overall shape of the chassis. And it's actually the glue, the aluminium glue steel of the chassis connection that's doing the job. All the rivets are doing is protecting the glue. You will get a significant increase in overall torsional rigidity in the chassis for adding this floor instead of this floor.
And it's all about the lightweights.
Yes, well, it's all the same weight, but you might as well have the more expensive stuff that does an extra rigidity adding job for the same money and weight instead of the stuff that is a bit wibbly wobbly.
While we're here, do you want to look at a proper Locost?
Right. Well, you find me mid project or mid various projects on this.
So what's the current project?
What we have here is quite an aggressive rear wing, but it's a two-plane wing. Without going into the aerodynamic theory of it, basically the angle of attack of this wing is calculated as the angle between this leading edge and this trailing edge. This is a very aggressive wing, which means that you've got it gives you a lot of downforce, but at a high drag penalty.
Right.
You don't need the downforce the majority of the time, so just like in F1, we've gone for a DRS strategy. So it can do that at the push of a button. And if you come around this side, I'll show you how it all works. A central locking actuator of something to one of the universal
I could almost
eBay.
hazard it might be TVR spec.
This probably is TVR spec. So this will be wired to actuate up on the push of a button that I have on the dashboard, but with the help of a few relays, powered down on the pressure switch for the brakes. This funny piece here is an aerodynamic aid because all this roll hoop is in the breeze. It creates an awful lot of drag. Mm-hmm. So what we're able to do by tailing this off, we reduce the coefficient of drag of the tubular profile into a teardrop profile. And it goes from something like coefficient of drag of 0.5 down to coefficient of drag of 0.5. Jesus. Without this piece, the wake you get off here diverges. So it starts to interfere with the wing and it makes the wing less efficient. With this piece on, it makes a converging wake, and by the time here, all the turbulence has largely reattached and sorted itself out.
So
and
you're
it's
getting
actually
clean air over the spoiler at the back.
You can see that it's very slightly angled down,
Yeah.
so that the flow of air should be hitting just under the wing here. We also have, you might notice that all 7 type cars have a bit of an issue with their wheel arches, that they trap an awful lot of air under, and you get lift problems. So you might notice on here I've used louvered vents, bought as doubles at £1.50 each from Tool Station, I think. Painted with also Tool Station's own spray paint. It's not the ideal solution because it's a, shall we say, a lift reduction strategy rather than a downforce creating strategy. We have a cleverer way of doing this. So we will be making pieces that go like this. The difference in those being that this will create a low pressure area back here and actively evacuate the air from the wheel arch rather than just equalising the pressures. Something similar happening on the front, as you can see. Offcuts of fakey jakey carbon fibre ABS. They will go from about here. You can see these are all my experimental trip strips that I was using to just work out exactly where the air needs tripping up. These are wrong. These are drastically wrong. It needs to be much higher up. As the air flows over the top here, there's a layer that wants to cling to the wheel arch.
Yeah.
And then that creates low pressure back here, which in turn creates a whole load of drag. So by tripping the air up just with a little lip here so it can't attach down here, you make a significant reduction in drag.
That is a lot to consider, but we are close to bodywork, so I will definitely bear it in mind.
That's one big pile of aluminium. But on the plus side, I have just lifted in the guts of the entire car's worth of sheeted aluminium with ease. So this stuff's definitely going to be light. The question is, have I measured it right? Hold up lads, I've only gone and finished something. Check that out. Nice bit of adjustable upper rear arm. Yeah, we've got a bit of excess, but once I've got the other side of this threaded on and chopped down, that'll be neat as can be. What have I promised for next week? Well, that has been completed, so we need to use the same jig principles and make some lower arms. Not gonna lie, they're gonna be slightly more complex than this guy just because of the location. However, I think this will be strong enough to hold on 1.8 litres of MX5 power. To everyone who's been following the project up to Christ knows what episode this number is, thank you very much for the support, especially those who've been with us from the start, because it's been a long journey and we're clearly nowhere near finished. But I promise the progress will start to come thick and fast. It's all very exciting. Very soon we're also going to be looking at having the rolling chassis, so if you haven't smashed that subscribe and link and bell and all that jazz, get it done now. To all our Patreons are probably running up the side of the screen now, massive thank you. That is helping stuff like this happen. Honestly, the more support I get from you, the more wild this will become. For everyone who's been with us, I really do appreciate it. Until then, we'll be back next week with another episode. I can't promise it'll be low cost because I've got crazy ideas going on at the moment, but it'll definitely be something. Until then, catch you later guys.
I thought your inner teenager was coming out.
Why?
Getting your phone out in the middle of doing anything.
I'm not listening to you because I've got my phone out. Ear holder.
I don't think I'd like you anymore.
I don't think you measure all that well.
You used to do it all.